Today we have this special function, the exponential function with non-base e, and this is special form for the integration and the derivation for this type of function. You see how it is look like. The integral a to the power g multiply g dash. This is the derivation of this function. So the result for this integral, it will be a to the power g divided by ln a. What is a? A is any real numbers, and gx is a function in the variable of x. So a, it is any real numbers. For the derivation of this type of function, we will keep a to the power gx, we will keep it as it is, multiply. We will find the derivation of g multiply ln a. So this type of function, you need to memorize how to find the derivation and how to find the integrations. You should memorize how it is look like, because we will use it to find the solution for the integral and the derivation. Let's see another point. The properties of this type of function for each of the real number u and v. The ability to convert division into subtractions. As you can see here, we compare the division to the subtraction. The possibility of the sum of the exponents when the two bases have the same value. Two bases have the same value, we can add the exponent. U, it will be u plus v. Let's see another one. The possibility of multiplying the exponent. If we have this form, we can multiply the exponent. It will be u multiply v. The possibility of distributing the exponent. We can distribute the exponent. If we have it like this, we can distribute. It will be a to the power u multiply b to the power u. Or if we have in the division form, we can distribute the exponent. It will be a to the power u and b to the power u. Let's go directly for the examples. Find the derivative of the following function. We have this function. How we will find the solution? Same as previous lectures, same concept. We will just apply the direct application for this formula, for this type of exponential function. So here, we just we will keep it as it is, and multiply. We will find the derivation of gx. It will be g dash multiply ln a. So find the derivative of this function. So this one we will keep it as it is. We will put it as it is, multiply. We will find the derivative of this function. It will be the derivative of this one. It will be 4 plus 2x. Multiply ln 2. It's just direct application. Simple. Let's go to see another example for this function. How we will find it? Same. Remember, we will use this formula. So we will 9 to the power root x, we will put it as it is, multiply. We will find the derivative of the root x, multiply ln 9. Simple. What about this one? Same concept. We will put the function as it is, multiply. We will find the derivative of this one, multiply ln 4, because this is the base 4. Same. We will put the function, we'll keep it as it is, multiply. We will find the derivative of this function, multiply ln 3. Let's go to see what about the integral. Find the integral of the following function. We have this function. Let's see how we will find the integral. Remember, the integral for this type of function, integral a to the power g multiply g dash, which is mean the derivative of gx. It will be a to the power g divided by ln a plus the constant number. So we need to find the derivative. We need to put the integral in this form so we can get the result of this integral for this type of function. So we have this one. What is the derivative of this x? It will be 1. So it is already in the special form for the integral. So we will keep it as it is, divided by ln a. It will be ln 8 plus the constant number. For this one, what is the derivative of 3x? It will be 3, so we will multiply 3 in numerator and denominator, and we get the special form. So the result, it will be 10 to the power 3x divided by 3 ln. Same idea for all these functions. What is the derivative of this minus 2x? It will be minus 2, so we will multiply minus 2 in numerator and denominator to get the special form for the integral for this type of function. So it will be this 5, we will put it as it is, and divided by ln 5, 2 ln 5. So what is the derivative of this one? It is 3, so we'll multiply 3 here and here, and the result of the integral, it will be the function, we'll put it as it is, divided by ln 2, and don't forget the number 3. Same concept here, just direct application for the integrals. So what is the derivative of gx? Divided by, we will multiply, we are missing only the two numbers, so we will multiply 2 here and here to get the derivation of this function of the root x. Finally, this is the special form. This function 10 to the power root x, we will keep it as it is, divided by ln 10 plus the constant number. For the other one, for this function, we need to use the properties to simplify the function. It will be 2 to the power x multiply 2 by using the properties. It will be equal, after the simplifications, we will get this result. After the simplification, we have this. What is the derivation of x? It is 1. So already in the special form, so it will be, but this is the gx, it will be, we put it same as it is, divided by 2, this is the 2, ln 2. Same here. What is the derivative of 2x? It will be 2, so we will multiply 2 in numerator and denominator. We will get the special form for this type of exponential function, and we will have the result. So also for the last integrals, we will use the same concept. What is the derivative of this function? It is 8x. We have 2x, so we will multiply by 4 in numerator and denominator to get the special form for this type of integrals, and finally we will get the final result. This is for today's lectures, and see you next time.